On the 17th of April 2026, NASA sent a command to Voyager 1. It took roughly 23 hours to arrive. The command told the most distant machine we have ever built to switch off part of itself. The low-energy particle instrument had worked for almost 49 years. Then, 3 hours after the command reached it, another piece of Voyager went dark so the rest could stay alive. This is Cosmion. Point it at any question in the universe, and it will show you the answer, whether you can bear it or not. Tonight, we point it at the furthest machine we have ever touched. We follow its signal out past the planets, beyond the edge of the sun's protective bubble, and wait to hear how the story ends. Voyager 1 is more than 25 billion kilometers from Earth. At that distance, a message moving at light speed spends almost a full day crossing the dark. Send a command now, and nobody can know whether it worked until nearly 2 days later. 23 hours out, 23 hours back, the conversation has become slower than weather. Yet the conversation continues. A dish on Earth listens for a radio signal so weak that every working part of Voyager depends on us finding it inside the noise. Only 2 science instruments remain switched on. One measures magnetic fields, the other listens to waves moving through the thin plasma between the stars. Everything else has either failed, finished its job, or been sacrificed for power. Voyager loses about 4 watts every year as the plutonium inside its generators decays. 4 watts does not sound like much. Out here, 4 watts is another decision about which part of the spacecraft must never wake up again. To understand why we are still making those decisions, rewind to 1977. Voyager 1 left Earth on the 5th of September. Its computers could process about 8,000 instructions each second. Its task was direct: reach Jupiter, reach Saturn, and send back whatever it found before distance or radiation killed it. Bolted to its side was an object that had nothing to do with navigation. A gold-plated copper record, packed with sounds, pictures, music, and greetings from Earth. The record was not a distress signal. It was a message for an encounter nobody expected to happen. If something found this machine after its makers were gone, the disk would explain that a living world once built it. In March 1979, Voyager reached Jupiter. The planet filled its cameras with storms wide enough to swallow Earth. Then a navigation engineer looking at the moon, EO noticed a strange plume rising from its edge. It was a volcano erupting into space, the first active volcano ever discovered beyond Earth. Voyager had reached its first world and immediately found something nobody had predicted. 20 months later came Saturn. Voyager crossed the rings, measured the atmosphere, and passed close to Titan. Titan's gravity bent the spacecraft onto a path no engine could reverse. From that moment, Voyager 1 was leaving the plane of the planets for good. There would be no Uranus, no Neptune, and no turn home. Saturn was both a destination and the door closing behind it. The planetary mission was over, but one picture remained. Carl Sagan had spent years asking NASA to turn Voyager around and photograph the family of worlds it was leaving. Engineers resisted because the maneuver carried risk and the cameras were about to be shut down. On the 14th of February 1990, from 6 billion kilometers away, Voyager looked home. Earth did not appear as a world. It occupied less than a single pixel, caught inside a stray beam of sunlight. Every city, every border, and every person alive was inside that faint blue point. That photograph was one of the last things Voyager's cameras ever did. NASA switched them off to save power. The machine that had shown us Jupiter and Saturn became blind and kept traveling. The sun grew smaller, but its influence did not end at Neptune. A wind of charged particles streams out from our star and inflates a vast protective bubble around the planets. Voyager crossed the outer edge of that bubble in August 2012. Its instruments detected particles from the galaxy taking over from particles born near the Sun. Humanity had placed a working machine in interstellar space. That does not mean the Voyager has escaped every part of the solar system. The distant Oort cloud still lies ahead, and it may take about 30,000 years to travel beyond it. But the material touching Voyager now comes from between the stars. Since then, the probe has done something no other machine can do. It measures that interstellar material where it actually is, then whispers the result back to the world that launched it. The whisper has survived failures that should have ended the mission. Engineers have recovered garbled data, revived old systems, and worked around hardware nobody can replace. They are not keeping a museum piece alive. They are operating it, one delayed conversation at a time. But engineering cannot stop radioactive decay. The shutdown in April 2026 left Voyager 1 with its magnetometer and plasma wave instrument still gathering science. NASA believes careful power management could keep at least one instrument operating into the 2030s if nothing else breaks first. There will be no dramatic final explosion. Voyager will not fall into a planet or burn against a star. Its last day as a working spacecraft will probably look ordinary. A dish will call. The command will travel for almost a day. Somewhere beyond the sun's bubble, the antenna may answer with engineering data, a magnetic field reading, or one more pattern of plasma waves. Then, one day, the answer will not come. The team will try again. They will wait through the outbound light time, then through the journey back. They may ask larger antennas to listen. For nearly 2 days, nobody will know whether Voyager is silent or merely faint. If the line stays flat, there will be no voice on the other end to announce the mission is over. A machine launched in 1977 will simply stop answering in the 21st century. Voyager will not stop moving. With no air to slow it and no destination to catch it, it will continue around the Milky Way long after its power is gone. In about 40,000 years, it will pass within roughly 1.5 light years of a star called Gliese 445. That is not a visit. It is simply the closest appointment on a journey with no planned end. By then, the radio will be cold. The computers will be dead. The cameras will still face whatever direction they faced when their heaters failed. The Golden Record will still be attached. Human voices, rain, footsteps, music, and a map, pointing back to a planet that may no longer be recognizable. Voyager's greatest achievement was never that it escaped us. It is that a machine built by people who knew they would never see the end of its journey was sent anyway. We gave it our instruments so it could measure the dark. Then we gave it our music so the dark would know who had done the measuring. Long after the last signal disappears, Voyager 1 will carry the simplest message humanity has ever sent. We were here. We looked up. We reached out. The lens does not blink. Subscribe if you want to be here when it turns back towards the sun, to the storm that once set telegraph wires on fire, and what the next one would do to a world run by electricity.